In this video, we're going to discuss permutation of non-distinct items without replacement. And there's a certain formula that you need to use with that. So we start with the question, how many different 10-letter words, real or imaginary, can be formed from the following letters? And then there's the list H, T, G, L, Z, T, V, L, L, G. First thing that you need to understand in order to do this is you need to know the formula. And this is the formula for permutation of non-distinct items without replacement. And it starts with n factorial over n sub 1 factorial times n sub 2 factorial times n sub 3 factorial, and it goes all the way out to n sub k factorial, where k is going to be the number of items that we have. And when we talk about n sub 1, n sub 2, and n sub 3, we note that in our given set of items that there are different ones. However, if we go ahead and alphabetize these, you'll notice that there are some groupings. For example, G occurs twice, so there's two of them, and L will occur 3 times, so there's 3 of those. And T also occurs twice. And then the rest of them, we have one H, one V, and one Z. And if we go ahead and add those numbers together, that's our 10 items in our particular arrangement that we're looking at. So keeping in mind that in permutations and statistics in general, the letter N is going to represent the number of items. This is going to be your total number. And then each one of these subsequent n's in the denominator are going to represent groupings of your items. For example, this right here is going to be your n sub 1. This will be your n sub 2. This will be your n sub 3. This will be your n sub 4. This is n sub 5. And finally, n sub 6. So we actually have 6 distinct items, but 10 non-distinct items. And remember that we're using the term factorial. And if you're wondering what that means, that's what this symbol represents. This is math speak for factorial. Now, of course, you need to know exactly what a factorial is. For example, if we talk about 3 factorial, that's saying that we're going to multiply 3 times the next number below 3, which is 2, times the next number below that, which is 1. So then we have 6. 4 factorial, it would be 4 times 3 times 2 times 1, which in that case would be 24. So now we need to go ahead and determine what all our n's are. So remember that we have, in this particular case, n is equal to 10. This is our total number of items. N sub 1 is going to be equal to 2, and that's going to be the G's. N sub 2 is equal to 1, and that represents H. And then we continue to do this. And so, as I said, n sub 1 is 2, that represents the G's. N sub 2 is 1, which is H. N sub 3 will be 3, which represents your number of L's. N sub 4 is 2, which represents the number of T's. N sub 5 is 1, which represents the number of V's. And N sub 6 is 1, which also represents the number of Z's in this case. Which means that I need to go ahead and create factorials for each one of these. We'll go ahead and write this first one as 10 factorial. This will be 2 factorial, 1 factorial, 3 factorial, 2 factorial, 1 factorial, and then 1 factorial again. Now to create our permutation, we'll take this first one, and that's going to go into the numerator. Everything else will be multiplied together in the denominator. So we'll have 2 factorial times 1 factorial times 3 factorial times 2 factorial times 1 factorial times 1 factorial. And if it makes it easier for you, go ahead and put the little multiplication symbol between each one of these so that you know how many times you have to multiply out. The best way to do this is with a calculator, especially a scientific calculator that uses or has a factorial key on it. Okay, so to use Web 2.0 Calc, you just need to go to WEB, the number 2, dot, the number 0, then calc.com. This is a great online scientific calculator. Now, one of the things that you need to remember for this particular problem is that we're going to have 10 factorial divided by the quantity 2 factorial times 1 factorial times 3 factorial times 2 factorial times 1 factorial times 1 factorial. So what I would recommend is going ahead and putting these in parentheses in your calculator when you do the calculations. So we'll type in 10 factorial. Now there is no factorial key on this particular calculator, but what you can do is use the exclamation key, i.e. shift numeral 1 on your keyboard. So I type in 10, shift 1, and you'll see that it types in the exclamation key. And one of the cool things about this is everything that you type in the window is going to eventually be displayed up here, and you'll see how it's supposed to be calculated. For example, when I put in the division symbol, which I'll either left click the division symbol here on the keyboard, or I can use the slash key on my keyboard on my computer, you'll notice that it creates a fraction. And then I'm going to go ahead and put in the parentheses, and you'll notice that it opens parentheses. And now I'm going to type in 2, and then I will do the shift 1 again. Now I can do one of two things. I can go ahead and click the multiplication sign, or I can type it in as 1 factorial. But I want to make sure that the calculations are done correctly. So this will be 1 factorial. Then we're going to multiply by 3 factorial. Then we're going to multiply by 2 factorial again. And it's pretty easy to correct any mistakes that you might make. And then we'll multiply again by 1 factorial. And then we'll multiply again by 1 factorial. Now you need to make sure that you have all of your correct values in here as according to what you've written down. So I do have a total of 6 factorials in the denominator, which is going to be 2, 1, 3, 2, 1, and 1. And then I have the single 1 in the numerator. Then I'm going to left click equals, and that gives me my answer of 151,200. What does that mean? That means that there are 151,200 combinations of those 10 letters. And you're going to do any arrangement of non-distinct items like this, as long as there is no replacement.